Hey everybody, we're going to complete our look at the probability chapter review. There are 20 questions left. 10 of them are going to be for me to do with you, and 10 of them are going to be for you to do on your own and get checked today. So hopefully what we do together gives you a little bit of a jump start on what's going on here. So we're going to jump right in with number 15. You have a group of 5 math teachers and 8 science teachers. In how many ways can a committee, now by the way, committee is one of those key words that we listed when we were talking about combinations. In how many ways can a committee of 2 math teachers and 5 science teachers be formed? Now back in the day there was an extra credit assignment that had a question like this, where you had 5 and you were choosing 2. It wasn't exactly these numbers, but we had 2 separate categories. We had 5 math teachers and we were choosing 2. We had 8 science teachers and we were choosing 5. Whenever you have 2 separate things that need chosen, you choose each one separately and then you multiply the results. So that's where the extra credit problem came in the other day. I was selecting 2 boys and 2 girls for a group. How many ways could you do it? You had to select the girls and then select the boys and then multiply the results. So that's what we are going to do here. We are going to do 5C2 and then 8C5, and then we're going to multiply the results. Now, I don't know if you're a formula person, if you're a blank person, it doesn't really matter. Either way, you're going to get something that looks like this. And 5C2 is 10. Alright, now, the 8C5 problem is going to be a little bit uglier looking, but it's not a big deal. And part of why it's not a big deal is in the end, when we do our multiplying, we don't even have to multiply the last parts. And we don't have to multiply the last parts because, technically speaking, if you multiply by 5 and divide by 5, multiply by 4, divide by 4, that just cancels out. And there's actually more you could do. If you were practicing your mental math, you could do 1 times 2 times 3, which is 6, and then you could cancel that out with the 6 that's up there. I mean, there are so many different things you could do. But either way, you're going to end up getting 336 divided by 6, which is 56. So long story short, we have 10 for this. We have 56 here. And then how many committees of math and science teachers could be formed? You just multiply those numbers. And your answer would be 560. Alright, looks good from here. Let's keep going. How many different codes can be formed using 4 digits if repeats are not allowed? You know, there have been more people who have really struggled with these pin number problems and that sort of thing, these codes. So it's probably good that it came up here. I'm doing the odds, you're doing the evens. Repeats are not allowed. Now, whenever we think about how many digits we can use for something, we always think of 10 because you can go from 0 to 9. You can choose 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. But here's the thing, repeats are not allowed. So as soon as you have chosen 1 digit to use in the code, you cannot use that digit a second time. So the numbers in the blanks keep going down by 1 every single time. So what you end up getting is 10 times 9 times 8 times 7, which would be 5,040 codes. Now, if you were allowed to repeat digits, then you would just do 10 times 10 times 10 times 10, and you would get 10,000. All right, number 19. In how many ways can you rearrange the letters in the word music, and what about musician? So this is a this is another example of a permutation because the numbers in the blanks keep going down by 1 every time. As soon as you have chosen a letter, you cannot use that letter again, so the number keeps going down. Okay, 5 times 4 times 3 times 2 times 1. So the number of ways that you can rearrange the letters in the word music is 120. Now I threw musician in for 2 reasons. Number 1, it's a longer word, so it's going to be annoying. Number 2, it has a catch, and we have not talked about this catch. The famous example that people use is always Mississippi. How in the world would you figure out how many different ways you could rearrange the letters in the word Mississippi? And I might do that example here in a second, but right now I'm just going to focus on the one that you have in front of you. All right, there you go. The reason the word musician is different than a word like just music is that you have 2 I's. So does it really matter which I goes in which spot? I mean, if I were to switch the letter I's, would anyone notice? That becomes the question. And so what ends up happening here is there is a little bit of a combination wrapped inside this permutation. That seems like a weird concept here, so I just want to go over it again. You have to divide out the repeated I's because there's no way of tracking which I is which. Okay, so you divide by 2. You take your final answer here and you divide by 2 because you need to make sure you understand that the repeats go away. Now, I think I know the answer here, but I'm just a little bit nervous about it, so I'm going to throw it in there. All right, there you go. So you get 40,320. But then you have to divide by 2 based on the repeats. Now, by the way, technically, when you have a repeated letter, you're not dividing by 2, you're dividing by 2 factorial, which is still 2, don't get me wrong. But I bring that up because if you have 3 repeats in a letter, you divide by 3 factorial. You have to do the combination count up to 3. Or if there are 4 repeats of a letter, you have to divide by 4 factorial because you're doing a combination count up to 4. Okay, so that's where the word Mississippi comes in. That's why it's always the one that that math teachers give to see if their teacher, if as a teacher you have really taught it to the students. Okay, so real quick, little side note here. I'm just going to scroll down and we're just going to talk about it. So if you were to try and figure out how many different ways you could rearrange the letters in the word Mississippi, there are 11 letters total. Now, instead of going 11, 10, 9, 8, 7, 6, instead of writing it all out, I'm just going to do 11 factorial because we need to save the time. This problem is enough of a mess as it is. Now, there are 2 letter P's, so we're going to divide by 2 factorial. But then this is where it gets really crazy. There are 4 letter S's, so we're going to divide by 4 factorial. And then there are also 4 letter I's, so we're going to divide by 4 factorial again. So what you end up getting here is 11 factorial, which ends up being really big. Now this number right here is 8 factorial. So if I were to just take it and divide and then multiply it by 9 and then multiply it by 10 and then multiply it by 11, you would get our numerator. But then you could take the denominator. Remember, factorials are just going from the number all the way down to 1. And now, I don't know if you've noticed this, but there is a joy in this chapter of not ever getting a decimal or a fraction as your final answer whenever you're doing a permutation or a combination. So this will divide evenly. You end up getting 34,650 ways. So what's interesting is you could actually arrange the letters in musician in almost as many ways as you could rearrange the letters in Mississippi. Okay, so remember that problem, because that's, like I said, it's one of those that math teachers everywhere just throw in there just to try and see if the kids get the pattern. So, all right, let's do the last odds that we're going to do. It's going to be from 21 to 33 here. We'll do the odds. What is the probability that a 4 is spun on a number wheel that's divided into 20 sections? Well, if there are 20 sections, there's only a 1 in 20 chance that you are going to choose a 4. 1 out of 20 is the same as 5%. What is the probability that a factor of 12 is spun? So now we're talking about 1, 2, 3, 4, 6, or 12. There are 6 possible ones. But I'm not going to leave that as 6 out of 20. I'm just going to go right to 3 out of 10. Otherwise known as 30%. All right, the probability that the spin is a negative number. I never said there was a negative number available. I'm just going to call that 0, otherwise known as 0%. All right, the probability of 2 consecutive 5s coming up. So you have a 1 out of 20 chance that you're going to spin a 5. Now, the probability of doing it a second time does not change. It's just a spinner. And that's sort of the same idea as what you are going to get when you roll the dice. Your probability is not going to change based on when you roll them. You're going to get the same probability both times. But since you have to roll it twice, you're going to do 1 out of 20 times 1 out of 20, which is 1 out of 400. You have a 1 in 400 chance of doing that. Now, if you were to find the percent of that, 1 out of 100 is 1%. So it makes sense that 1 out of 400 is actually 1/4 of 1%. So again, not very likely, we'll say. All right, now the difference between the top section and the bottom section is that this time you are keeping the card in your hand, which means your probability for the second draw is going to be different than your probability for the first draw. Okay? And there is another way of looking at it as well, and you know, we'll talk about that just to make sure we've covered our bases here. Both cards are red. So we had the card example before. I think we did a pretty good job of getting into it. There are 52 cards in a deck. 26 of them are red. As soon as you have chosen one of the red cards, now you only have a 25 out of 51 chance that the second card is going to be red like the first. Okay, now the setup for this, I told you I was going to talk about it the other way. if you were treating this like a combination, and it is technically a combination because order doesn't matter when you're choosing these cards, it would look something like this. There are 26 red ones that you want to choose. There are 52 total cards that you want to choose. So it would be 26C2 divided by 52C2. So you really do have a couple different ways of looking at it. I think the easiest way to look at it would probably be just to recognize that 26 over 52 is just the same as 1/2. Because now you could just do 25 times 1, which is 25. 51 times 2, which is 102. And then you don't have to worry about reducing the fraction because that is as far as it will go. As far as percents are concerned, 25 divided by 102 would give you 24.5%. All right. 2 more questions and then we are done with my part and you'll be on your own. Both cards are the same value. 2, 3, 4, etc. So what is the probability that you will get a pair? Now this one you have 2 different approaches. You could do one of 2 things. Option 1 would be to find the probability of getting a pair of 2s, let's say. And then multiply by 13. Because your probability of getting a pair of 3s is the same as that, just like the probability of getting a pair of 4s, or 5s, or 6s. So if you figure out the probability of getting like a pair of 2s, and then you take that number and multiply by 13, you'll get what you're looking for. Now I have another suggestion, and option number 2 is the one that I am going to choose. So pay attention to that because that's going to be the one in red. And that's going to be to break it down the way we did number 29. Now there's a really interesting point here. If you're looking at your first card, what should your first card be? Here's where it's interesting. It can be anything. We don't care what the first card is. It could be anything. The only thing that matters is that the second card matches the first. So the first card could literally be anything. The second card is what matters. Because once you have drawn, let's say, a 5, now you only have 3 other cards that match it. Or let's say you drew a 7 first. There are only 3 other cards that match it. So that's where I think the problem takes an interesting turn. You can do it the first way, but I think it's easier to look at it in terms of the second way. Because option number 2, 52 out of 52 is just 1. 3 out of 51 reduces to give you 1 out of 17. And that is the answer to the question. Okay. Now, as a percent, you would end up getting 5. I'll go a couple decimals this time. It doesn't matter. That's a battle I'm not really fighting in this chapter here. I just want to make sure people get the idea. 5.88%. All right. Last problem that I am doing here. Both cards are less than 7. Okay, now in this case we are going to assume that aces are high and not low, so we're not going to count an ace as being less than 7. We're just going to count the 6s, the 5s, the 4s, the 3s, and the 2s. So out of the 52 cards, 20 of them are less than 7. Until, of course, you have drawn one of them, because now there will be 51 cards and 19 of them will be less than 7. So what you end up getting here, 20 out of 52 reduces, so I'm going to get rid of that, and I'm going to just call it 5 out of 13, just to hopefully clean this thing up a little bit. But that's still not going to clean it up a lot, because 19 and 5 are both prime numbers, and so is 13. So this is really not going to reduce very well. So 19 times 5 is 95. And then 51 times 13 is going to be 663. And hooray for us, that does not reduce at all. So that's pretty insane. So you get 95 divided by 663, which is going to give you a very weird 14.33%. All right, so again, today we did all the odd numbered problems together. You are in charge of the evens. That would be 10 problems that I need you to give a shot on your own. This is pretty much the last thing we're going to do before we wrap up the chapter. So you can expect an online quiz sort of thing coming up tomorrow. I guess that would be fitting because it kind of goes back to our old rules about Thursdays. So anyway, I hope this helps get you going here. Have a great day. Take care of yourself and take care of each other.